Everyone, we are now in the seventh module. First of all, thanks one and all who made the sixth module a great success. With all your help, we have achieved the Guinness World Record. It was a great achievement. I've been seeing a lot of uh, comments in the chat box stating that they have attended, they couldn't get the certificate. We have already shared the mail ID to all of you people on how to log into the shop and download your own certificate. Don't pay any money to NBMS. You need to buy your own certificate. All those who attended on that day got mails. Okay, you need to go to the Guinness World Records, the shop area, register yourself, navigate to our particular event, and then pay the amount to get your personalized certificate. So we are going to post a video on how to get the certificate. You don't just take that into the account. So let's focus on today's lecture. So to take us through this, we have Mr. Sumit Kumar Singh. He is a founder of Garage Lab Technologies, IIT IIM alumni, continued to do his education in Harvard. He educated more than 70,000 people on the AI. You can see one of the champions who can just, he's there with us to take us through the concepts of machine learning, even if you don't know anything about the math. And to moderate the session, we have Dr. Ramakrishna, who is a nephrologist by profession, AI enthusiast. He created his own models using AI, which are across the globe, I can say very confidently and proudly. Over to you, Mr. Sumit, for the actual lecture. I'll keep myself mute.
Thank you so much, Doctor. And massive thanks to, of course, NBEMS for having me here and sharing my insights and learnings with all of you. A bit about myself. I am not a techie, so it should give you some sense of comfort. I have learned a lot of these concepts in an extremely simplified manner, which I'm going to share with you in an even more simplified manner. I'm trying to demystify the entire core concept of what machine learning is and how it actually can, help you eventually taking it, making it better for all of you. So why AI and ML matter in healthcare essentially is for a very simple reason. We have a lot of data that's coming to us in our traditional offline world when we are running our clinics, our hospitals, and our nursing homes. And the velocity at which we are actually getting this data and the variety of clinical data that we are getting, we are not able to analyze it to the best possibilities, via which we should ideally be able to make sense of what it is happening and do better judgments and manage our operations and businesses, everything a little better. So machine learning really gives us the tool to find meaningful patterns within that entire complexity, right? The big opportunity essentially here sits at earlier detection of deteriorating patients, extremely personalized treatment paths, and reducing diagnostic errors. And this is one of the first line of diagnosis essentially. ML and AI have been able to really, and we have some numbers that we'll share with you as we go along. They've been able to really predict in which line of direction should doctors essentially, take it forward. And at the same time, AI and ML, purely because it's so scalable, they're actually making the equitable access to specialist level insights at at a scale, so to say. Jumping into the core topic of what is machine learning, it's super simple to understand. You have some data, you learn some patterns from some data, you teach the machines how to identify those patterns, and using your clinical insights, you're actually able to predict what the machine ideally should be able to mimic your behaviors. So showing thousands of patient cases such as x-rays linked to confirmed diagnosis. This is something what we call as a labeled data source. We know exactly what the data is. There is no ambiguity in that data. Everything is labeled. Everything is, have the names and columns, and everything is kind of, nicely done. Using these corrected data links, we then identify patterns, if what the markers are eventually going to be, what are the situations, what systems are eventually going to tell. You identify and understand those particular patterns, and using those, then the system starts to flag abnormalities purely on the basis of the original data. And if one marker or one number is here and there, plus minus 20%, plus minus 30%, whatever you eventually wanted to understand and you want the machine to predict, that's where clinical insights essentially come in. And that the feedback essentially goes back to the machines on what should be or what should not be. And that's something what we call them as rules. So you have the right kind of data, you learn the patterns. From those patterns, you identify anomalies, and then you keep defining rules, and the machine continues to learn. It is a super simple way of exactly how humans learn. We just extrapolate it super fast to the machines, and machines are actually able to learn it much faster. There is absolutely no rocket science to how we are actually now able to use machine learning. And maybe if we have time, we will be able to demonstrate a couple of things today to all of you as well. Now, oftentimes machine learning can be interchanged to a lot of things. So it becomes very important for us to understand what is not machine learning. And it's a very common source of confusion in clinical settings is the over labeling of diagnostics tools as AI, right? Now, ML is not, understanding what ML is not helps us to appropriate expectations and prevent both hype and skepticism. One of them, the most important one, is if you have a rule based system, which is a very simple if then else. Do you have fever? Great. Do you have vomit as well? Yes. If no, then which way should you go? And that if then else logic essentially is not what we call as machine learning. An if-then-else system is extremely deterministic. We can actually follow a tree along the way, and depending on which side or how many outcomes are we talking about, what kind of fever do you have? Is it more than 100? Give paracetamol. If it's less than 100, 99. If it's more than 100, how high it is? Is it 102, 103, 104? If it's 103, 104, give it Meftal. Don't give him, don't give the paracetamol to the kids because you want to really break the thing. And how many days has the fever been? A lot of these conditions are deterministic. And the moment it becomes rule based, it is not machine learning at all. So you have to understand, and everybody who's looking forward to learn a bit of machine learning, it gets very important to understand the nuances of where it's getting rule based and where it's not. Basic hospital software wherein we are putting health records is not machine learning. We are just storing data. That's it. We are not learning from these data sets. So that's the reason why we don't call that as a, you may be inferring using these hospital softwares. You may be understanding a couple of things, and purely your own subjective analysis. And that is not what we call as machine learning. Then we also have statistical calculations, wherein we are talking about how exactly are we producing a risk and what kind of lab values eventually going to be. How are your markers for your blood work are looking like, and all of those are stats. That's core data set. You can then do standard regression and other pieces on top of it, but that's again not machine learning. A definitive feature of machine learning is adaptive learning from data. It has to learn as you produce more data. You should constantly keep learning on top of it. If you're not learning from the if more data does not mean more learning for you, that is not machine learning at all. It's very, very simple. There are four pillars of machine learning in medicines, largely that we typically call off. And these four pillars can be supervised learning, unsupervised learning, and we'll quickly touch upon each of those, natural language processing, and reinforced learning. Supervised learning is one of those ways of learning machine learning wherein everything is nicely documented, everything is nicely labeled, everything is clean. So there is no ambiguity. What does it even mean? What does this column mean? Is this a integer or not an integer? Everything is nicely done, and that becomes my training data or the normal data. Unsupervised learning is wherein there is no data, there is no label. You don't know. There is just millions and millions of rows of data, and we have not identified if 35 can be the weight, 35 can be the age, 35 can be some other number. For example, like I'm not a doctor, so lack of a good example here, but 35 can mean a lot of things. Now, understanding in the right context of where exactly is 35, what is the variance with 35? Is 35 going to 3500 as well? So clearly it cannot be human age, it cannot be human weight. But if 35 is going to 75, 80, maybe 100, then maybe there are some ways. So there, the model essentially understands and discovers natural groupings within the data. Now, this data has to be patient level data for us to be able to make sense of it. And then, purely because it's patient data and natural grouping is done, we are able to then identify previously unknown subtypes and patient cohorts which were not available to us otherwise. So, we've been looking at label data, which has been completely humanified. Unsupervised learning helps us to identify new groups of data sets. This could be any smallest group possible wherein only 5 people are eventually sitting in. And this could be 1 in a million kind of a narrative. But all of that essentially is available because we have unsupervised learning available in our machines. Then we have natural language processing. It essentially extracts unstructured clinical text and then discharges summaries, radio reports, etc., and then unlocks data that never enters the structured fields. To be able to eat medicine before your breakfast, what would it mean in case if you're taking your medicine after breakfast? And what are the other symptoms around it? A lot of this might come around in your discussions. Are we recording these discussions? Are we learning from these verbal discussions that are actually happening inside of our clinics? Are we using them to train our models? That's really where this one particular natural language processing sits in, which really helps us to understand and uncover a few signals which we otherwise might miss out. And then we have reinforced learning. This algorithm, uh, in this particular methodology of algorithm, the model essentially learns by trial and feedback. It will tell you, okay, the fever is 103. We can give a particular drug, but what should be the drug? The drug capacity. What should be? Should you give 2 spoons, 1 spoons of syrup? Should you give 100 mg, 10 mg? Should you give with food, without food? All of that essentially that's actually happening here is because of we are doing a trial and feedback. You just administer something to the data, and then it learns from it purely from the basis of the previously one. You administer that, you get some feedback, and then you give that feedback to the data again, and there it's a continuous learning loop. Supervised learning is you have everything cleaned. Unsupervised learning is there is nothing clean, it's completely no labels. Natural grouping. Natural language is wherein we are really connecting data sets in a natural language. Very simplistically saying, the discussions that we have in our clinics. Reinforced learning is everything which is trial and error and feedback, and you're just taking actions and receiving rewards and penalties on the basis of how it's essentially going. One of the most widely deployed machine learning paradigm is a supervised learning. It requires a data set in which each example carries a known outcome, which is the label, and learns to predict that outcome on new cases. Now, predicting a category essentially is called as classification. Now, do you have a tumor? You may not have a tumor. Do you have a sprain? Do you not have a sprain? Do you have fever? Do you not have a fever? Do you have some other malignant or a benign? How exactly do you classify that? What numbers essentially are threshold numbers? And these may also change over a period of time. So giving a yes or a no is really where a classification model learns and stays around. We have regression, which is a continuous value. So a regression essentially predicts continuous value, as against classification, which is extremely binary. You have yes and a no, 0 and a 1. That's it. Now, on the basis of a 0 and 1, in case if our markers are moving slightly up and down, that's where regression starts to come in. Estimating a patient's length of stay, projected blood glucose trajectory, or survival probability at 30 days. These are all regression models which underpin many clinical risk scores which are enhanced with ML. So patient features over time, weight over time, numeric value of predictor probabilities, all of these essentially is where regression happens. And then these then go back to feed into our supervised learning models, and we put them as labels that, okay, this is a new value that we are now starting to do. Our our obese thresholds, or even our sugar thresholds, they constantly are moving up and down after every 5 years, 10 years. That's a continuous value. That's where the regression essentially sits in. So we are fine tuning and learning everything, and then we are coming up, and then so on the basis on the inputs of what regression is, we then use classification to say, okay, this is this or this is not this. Where ML meets the clinic is a very fascinating space, and this is where a lot of work actually is happening nowadays. There are 5 broad areas in which ML and AI is working. First is prediction, second is prevention, third is personalization, fourth is one of the most important is diagnosis, which is where AI assisted tools are actually allowing that first line of diagnosis at scale with people. And at the same time, in pathology side as well, we are talking about biomarker detections and protein detections and other things. In each 5 of these highly impactful areas, different models of machine learning works. Do you need to know? Maybe not, because AI will actually now help us do those kind of modelings with us. And you've already done the prompt engineering pieces. I'll probably share and show you how I would essentially try and do the prompt engineering piece. So maybe there is some learning for you there as well. So in prediction, and we'll take a look at it as we go along towards the end of the session today. In the prediction model, the model trains on vital signs, lab trends, and clinical context that can flag deteriorating patients hours before a clinical crisis happens. That's prediction. And sepsis prediction algorithms have demonstrated reductions in mortality in at a decent level. And I'm talking about decent level means anything above 85% is where the numbers are. Prevention is before symptoms appear, and you really kind of fine tune the models. You're just analyzing longitudinal records. We are really stratifying the asymptotic patients for preventive intervention, and if there is even a single thing which goes off, we take them into prevention care. Personalization is again very fascinating, and with AI it now allows us to do personalization at an infinity level. Every person is is extremely unique. No two patients respond identically to the same drug. And just being able to identify these markers, identifying the drug responses, the prediction models can now use genomic, proteomic, and clinical data to anticipate individual responses. Technology also allows us to administer and deliver these results at scale, and even the care at scale, at an extremely infinite persona level, purely because now we are able to customize the therapies on the basis of a lot of our learning that we've been able to do, which otherwise at human level we were not able to do, because now machines are able to do it and generate it. That's where Gen AI is eventually coming at. The diagnosis is very fascinating because AI assisted tools can now match and exceed a specialist performance in a screening task. Deep learning models are now getting far more evolved. There is a lot of research that's happening at Google, I know for sure. There is Meta that's also releasing a couple of their models to detect a lot of the diseases that we've ideally been struggling with. So, diabetic, pulmonary, and breast lesions. And these are all extremely sensitive pieces as well. So, what we are talking about is models that have been trained on millions and millions of data sets, and then they have been now deployed for B2B and B2C use cases. So we have a certain degree of confidence before these models have actually come to us. Similarly, we have biomarker detections. So these are some of the use cases where ML meets the clinic. Now, when we are talking about improving healthcare access with AI, there is this huge access gap at this point in time when we're talking about. Globally, over 4.5 billion people lack access to safe, affordable surgical and specialist care. In many low medium income countries, a single radiologist may serve hundreds and thousands of patients. You all have the data on number of doctors that are available to tier 3, tier 4, and even rural India today. A lot of doctors may not want to extend their stays in the rural. They would be more than happy to go and make visits. But what happens when the doctor is not available for a visit? That's where AI comes in as an equalizer. We have mobile diagnostics, we can have point to care detection centers, and we can even have a lot of other applications which can help you do extremely specialized care for each of the use cases. It can be sleep, it could be O2. We have the example of dermatology apps, point of care TB detections, and a lot of these models are actually now being deployed over a mobile. That makes it even more accessible, so you don't have to really do it. And this is one which is a very one of the amazing use cases of 2025. A retinal screening have been able to really achieve a specialist level accuracy at a fraction of a cost. And somebody was actually able to predict the kind of blood sugar and other pieces purely on the basis of retinal screening. And I saw a demo of this. I was blown away purely by just how fast the technology is actually evolving and actually helping doctors in doing better diagnostics. So this is in no way a replacement of doctors. No. What we are talking about here is technology working with clinical practitioners and now being able to achieve the speed and the trust that otherwise was not being able to achieve at scale. That's the scale is really where the big impact essentially is looking at here. The key stats, what we're talking about here in the clinical practice is that 94% diagnostic accuracy has been achieved in the dermatologist performance. And these numbers are actually public. So more than happy to share the report should you want it. We have achieved 20% mortality reductions, uh, because of ICU uh, prospective studies and how exactly are the machines able to really navigate the line 1, line 2, line 3 treatments, how actually we're able to do the predictions around sepsis. All of this, and there is so much more, and this is just some of the numbers that I'm sharing here. There are huge reports. I'll be more than happy to share the links as we go along. Um, the projected savings, purely because now you don't have to overload the healthcare system with repeated visits. And this number is driven by Accenture. So it's $150 billion of projected savings that we're talking about. And this is only US healthcare, purely because the data is far more structured and everything is kind of tracked. But imagine if we are talking about India and we are able to deploy something like this for an Indian market, wherein we are talking about AI-driven efficiencies. We are talking of a 3x or a 5x bigger number purely because of the impact that we are able to drive here. Um, a very interesting number which came here in all the reports is also something called as a clinical burnout, 45% reduction. The physicians report administrative burden as a leading driver, wherein people are just so, the healthcare systems are, they're so bombarded with so much of the mass that we have in India, the population that we have in India, and how we are actually looking to deliver and deploy these AI systems at scale. We are looking to decentralize a lot of these and really derive value by reducing this burden on extremely centralized pieces. And that I think is definitely is one of the most important impact of AI, because with doctors less burdened, the justifications and the jurisdiction, the decision making that they will be able to do is going to be far more accurate than when a particular clinical practitioner is actually stressed. He's not slept for more than 36, 45 hours, and now you're looking to kind of, do more, versus somebody who's just fresh out in the market, with a coffee in the morning. We're talking about a completely different scenario here. Right? How you can try machine learning? There are multiple ways. I will be demonstrating today something called as a Google Colab. It's a free tool available. We run Python environments. We can also load healthcare data sets in something called as a teachable machine, which is again a very fascinating Google, tool. Again, available for free, and you can learn how to do it. So I have just one more slide or two, three more slides. We'll come back to the slides. I really want to show how we can do, and I have here for so we are talking about age, gender, chest pain, and there are some in this one. Now, if I were to really do this kind of an analysis for health disease prediction, how exactly will I do that? So what I've done is I have a problem statement already copied here. So I'll, for the sake of simplicity, I will just use ChatGPT, and I will say that I have a problem statement to address in heart disease prediction. And I just copy paste this thing. What I'll also do is I will go and I'll paste the CSV file of this data as is. Help me run the analysis in Google Colab. And one thing which I often add in one of my all my prompts is that play a devil's advocate and find the gaps and fix it for me. Use RCT or tag or crisp framework to design the prompt for me. Lastly, give me the 5 bullet pointed summary as a medical practitioner. Now, when I give this, there are some very interesting bits that are actually happening in this particular prompt, and you've already gone through a module with Lakshmi, I remember. What I'm actually doing is I'm enhancing and taking these are some advanced prompting styles. So we take it back, and when we say play a devil's advocate and find the gaps, it's reinforced reasoning model that actually lets ChatGPT to play a devil's advocate and check on all the responses that it's doing. Then I'm also asking it to use certain key frameworks here, which is RCT, tag, and crisp. RCT, tag, and crisp are some of those jargons which ChatGPT kind of understands while designing frameworks. And when I say lastly, I did ensure that and also see that when I'm actually talking to ChatGPT, I am not answering it all in one big paragraph. I am putting it all into separate lines because that's how it dechunks the entire thing. And when I, after doing playing devil's advocate, RCT, crisp, everything, lastly, it is asking, I'm asked to give 5 bulleted pointed summary as a medical practitioner because I don't want a summary till the time it has not done this entire gap analysis and frameworks and everything else before. So if you see here, it is actually doing the model performance analysis, it is doing exploratory data analysis and all the other things that it is supposed to do. You can see the calculations, you can see the working of this model at this point in time, which your chat GPT is actually able to do. So you can actually do some extremely deep analysis, and using chat GPT, it runs a lot of very cool things for you. You don't really need to go to some other tool to be able to do it. But there is a challenge with ChatGPT that it may hallucinate, and that's the reason why I have asked it to run the analysis in Google Colab. For the sake of time, I will just skip this for now, and I will ask it to give me a downloadable Google Colab file, which will just run the entire analysis for us. I have, just to repeat while it's generating, I gave the problem statement. I'll just open the problem statement file here quickly. So my problem statement file essentially is saying that heart disease is something is easier to treat when it's detected in an early age. Problem statement says analyze the disease data set to explore machine learning algorithms and build a decision tree model to predict. We have the variable descriptions, and then the scope is given here to understand data by performing exploratory data analysis, training and building decision tree, understand feature importances, understand various model performance, etc., etc. Now, all of this is what we are asking ChatGPT now to do for us. So here it has understood the problem statement. It played around with the devil's advocate, improved prompt using CRISP framework, exact Google Colab framework and code, and it's kind of coming up. This is where the ML project framework is giving me the entire code, so I don't need to really worry about it much. This is the Google Colab sheet giving me all the libraries that I'm supposed to be running inside of Google Colab. Now, what I will do is I'm not a coder, right? I declared it in the beginning itself. I am not a coder. I want to run this in Google Colab. Give me a downloadable file so that I can bring it in Google Colab directly. Now this will give me a downloadable file. I'll just copy that downloadable file, go to Google Colab and run my analysis. Boom, and it's done. While it is generating, I will just quickly go over to my Google Colab. When you go to Google Colab, just search for Google Colab and you will come to this file here. And I'll click on new notebook. Now here I'm supposed to give you some stuff. Don't need to worry about it. You can completely ignore that. Now this sheet is where it should ideally start the entire story for you. I will go to my here. It has given me a Google Colab file. I'll just download this, which is heart disease Colab notebook, and I'll save it in my downloadable folder. I'll come back to my file and I will say open or upload a new notebook. In my upload notebook, I will go to my downloads, and this is the file that it just generated for me, and I will say open. And one thing what I will do is I will just upload my data. So when I'm uploading, there is a small folder thing here. It is connecting to enable file browsing. Just give it a second. Here I will just upload the data that we have. And it should be here, heart disease prediction, data set, CSV file, and I upload it. As soon as this file is available, it is ready. I will be able to see it here. I copy the path and I will say run all. Dismiss, it says okay, and I will say here is my file. It'll understand what my file is because I'm currently asking it to import this particular file. It'll work, it'll run, and this is ready to be loaded, and I just say run all. Asking for some permissions, which is absolutely fine. You can select all and give and continue. It is running at this point in time, as we can see. It is doing all of those data sets. It'll import, and at the end of the day, it will supposed to give me the file summary of everything that it's supposed to be doing. I'll just accept it. It is saying invalid syntax, which is fine. I'll ask for explain error. It understands all its own. You don't have to really worry about what it does. It understands. You just have to accept it and keep running, keep building it as you go along. Once you as you run this entire thing, you will be able to come and do the entire analysis that you're looking for in an extremely simple manner, and it'll even generate the charts for you. So do try it out. It's a very simple tool. And the paucity of time, I'll just quickly move to the next bit here. which is the role of doctors. And this is very important for us to understand while it's kind of running the Google Colab sheet on the background. The role of doctors in the AI era. It's important to understand and appreciate the fact that AI only brings pattern recognition at scale. It brings tireless consistency across thousands of cases. It synthesizes high dimensional data and speed in time critical situations. It is not replacing the clinical context and patient values. It cannot do that at all. It does not understand ethical reasoning and accountability. It cannot integrate with social and cultural factors, which you as doctors are actually able to do. Also, you have nuanced communication and empathy towards patients. AI is still far away from understanding feelings and understanding really how you should be handling a particular case. However, there is enough case and merit in talking about doing it together. Earlier, more accurate diagnoses are possible. The sooner you engage with AI, the more accurate diagnoses are actually available than taking it to the last stages. It is much safer and more personalized treatment because now you can actually personalize every line of treatment for each personal individual that we're talking about. It reduces a lot of clinical burnout because now you can build a clinical twin of yourself wherein somebody wants to just talk to a WhatsApp bot for yourself, for example. You could be a vet, you could be an eye doctor, you could be a GP, and if somebody is just wanting to speak with you and upload some prescription files and say, okay, I'm having fever, what do I do? And it's 2 a.m. in the night. You may not be awake, but your agent, your digital twin, may actually be awake at that point in time to give them the first line of treatment on the basis of the inputs that you have actually received, which allows a more equitable health delivery for doctors and for the healthcare system at scale for the masses. The most important skill for the next generation of physicians is not coding, essentially. It is a critical appraisal of AI evidence, and just as it's not as a clinical tool, just understanding where AI can be falling short, where AI can be hallucinating and bringing in some biases, and how exactly can you actually play around with each of those aspects and control, more importantly. AI is at best your intern. AI is not a subject matter expert. AI is not your friend or a foe. AI is an intern. The kind of directions you give to AI, the kind of responses you get, it's garbage in to garbage out. The way you talk to it will eventually bring it back to you. And understanding these AI patterns is really where the big wins are going to be. And you can even fine tune the responses and give it back to the machines. So the big key takeaways for today when we're talking about ML is that ML learns from data and it is not programming. You show and you throw the data back into the machines. It could be, and I'll this point in time, I'll just quickly go back to the 4 pillars that we had, which is we have supervised learning, wherein we have everything labeled, all clean data, correct data, just like we saw in this particular case. We have age, gender, chest labeled. There is no number which is missing. There is no number which is should not be in the range. So this is my training data set that we eventually show. Unsupervised learning has no labels. The model discovers natural groupings within patient data. Natural language processing, as we spoke about, these are records, these are outpatient notes and discharge summaries and discussions that you're actually having within the room when you're actually discussing the case. And reinforced learning is a mix of unsupervised and supervised learning both. So you train something, then you test something, it goes back, and that's essentially where you are making these machines learn. So ML learns from data, it is not programming. Clinical applications span the full care pathway from pre-symptomatic risk stratification and personalized drug selection to AI assisted radiology and natural language processing powered note analysis. ML is already embedded in frontline care tools, and there are some amazing applications of machine learning and AI deployed in the care systems. Access and equity are central to the AI agenda. If we are using AI for only a handful of adoption cases or handful of people, handful of use cases, then we are probably not using AI to the core of it. When deployed thoughtfully, Machine learning extends specialist level diagnostic capabilities to underserved populations, and that's one of the most compelling humanitarian argument for clinical AI adoption. And we can help you build a couple of things. We run garage labs. We are in that space wherein we are actually helping people adopt AI. So if should you have any requirement or any help, we are working with Vet Care Association of India. We are also working with a lot of doctors in Delhi, so helping them turn around their key clinic experience. So we'll be more than happy to do that. Doctors remain irreplaceable, and they must engage. This is the most important point that I really wanted to make. There is a lot of fear within the doctor space as well, and with a lot of others. And if AI is doing everything, then what's going to happen? But the clinical judgment, the ethical oversight, patient centered communication cannot be automated. It is not possible. AI is far, far away from all of this. We may be achieving an AGI and an ASI, which is super intelligence, etc. But ethical and responsible communication and practices is something which AI is far away from. Clinicals who understand AI will shape how it is developed, validated, and used responsibly. It is kind of becoming de facto because you are anyways using a lot of your chat GPT and Claude and Perplexity and Gemini to do a lot of things. You can actually 20x, 50x that entire experience for yourself as well as for your patients in more than one ways. So thank you so much, National Board of Examinations in Medical Sciences, for having me here. We have this QR code for you leaving here for you to join the community. We have more than 46,000 people in our community across the globe, across 17 countries. We do a lot of such kind of engagements with people on various topics. So should you want to engage with us on an AI narrative, please do join the groups. I'm more than happy to address any questions.
Thank you very much, Mr. Sumit. It's indeed a wonderful thing. I'm sure there are a lot of questions which Ramakrishna is going to moderate with you, I think. But just to reinforce to all the listeners and viewers, please do not spam the YouTube channel with the attendance or the Guinness World Record numbers. You will be getting mail once again because I'm seeing a lot of people entering the number and I don't see, I see few people are getting missed on those getting that. Don't worry about it. Enjoy the class now. Over to you, Dr. Ramakrishna, for the moderation.
Yeah. Thank you so much, Sumit, and very crystal clear, very lucid presentation you have presented very well. And I think the medical professionals who are not adopted to technology also could be able to understand from your presentation. So thank you so much. So I have been into clinical practice for the past 20 years. So
just one
what
minute. Ramakrishna,
yeah.
1 minute. So
Yeah,
you can
yes.
you can stop the screen sharing, sir, please.
Okay.
Stop.
Sure.
Thank you. Please.
Yeah.
Go ahead. Please, Ramakrishna, sorry to interrupt you.
Yeah, please. Sure, thank you. So we used to see so far one size fits all approach. So that means we see patients who are sick and we provide only reactive fragmented care. But once this ML and AI started appearing into healthcare, we are actually trying to improve a sick patient towards a healthcare, towards real health we are seeing into the patients. So transitioning from a reactive fragmented care to 4P medicine. That means predictive, preventive, personalization, and more proactive approach to our patients. So that we are able to improve their lifespan, health span, and quality of life. I have a small doubt here. These ML algorithms are foundation models and ML algorithms are started in US and European data. Okay, even today, 90% of Indian medical data is manual and paper-based. So how come predictive models in US based upon their American data could be applied to Indian patients?
Sure.
And these
It's a brilliant
algorithms,
question.
these algorithms are actually studied, read, validated, trusted, and trained in Western data.
Correct.
At that point of time, we had been in, even now, the Indian digitization in healthcare did not happen fully. So I think bias will be a major problem for using their ML algorithms into our Indian patients. So there should be some federated learning to avoid this bias. Can you throw enlighten on these aspects?
Certainly, sir, and thank you so much for the question. It's a beautiful question, and that's exactly where I meant that we cannot replace doctors. Not, and there is a lot of ethical, there is a lot of world context that's supposed to happen in the kind of Indian patients essentially are the kind of healthcare systems that we are sitting in. There is a lot of unlearning of the data that needs to happen, which is where we have to fine tune the model, so to say. Of course, we don't have a lot of digital data, but there are some great hospitals who are anyways working towards it. One thing what we can do is we can, in our own local context, we can train our own data. If we have, let's say, if we have anything in paper also, that can be now AI allows us to click a photograph of a prescription and digitize that. We can even tell the models and tell ChatGPT to get only the records and not personal information. And it will do that for us. It will not store that information. We can tell GPT to prepare a trend of all the 100 images that we have uploaded and understand what that essentially means. So earlier used to be something called as an OCR, and there was a huge technology, money that used to be invested in
Yeah.
that. But ChatGPT now allows us, and even Gemini allows us to now extract text at a fraction of a cost. So you can actually do that, get thousands of images into ChatGPT, get it to put together in an Excel sheet, all in a single prompt, and then just actually go ahead, not just get the data, also do data analysis and train that model, saying that for Indian context, use this as a surrogate learning. So the learning essentially is, but this learning is again not, it's a super reinforced learning, but this learning is not at a scale level. So there is definitely have to have some other at a regulatory methodology, at a regulatory, at a government level, some interventions need to be done to get data and actually invest in research. It could be with AIMS, could be with Shivnagar, could be with IITs of the world that we have, and join hands with them to actually build India-specific models, something what Sarvam has done for languages.
Okay, and one more thing is, so how do you say that a particular ML model is actually so transparent, which is working for the patient? So how do you assess the efficacy of the ML model that is actually working for the patient?
Right. So there are certain numbers, sir. When we're doing the analyses, there are some R square numbers and fitment numbers, which is why when you're doing and running these experiments and running these analyses in Google Colab, it gives you these numbers. Versus if you want to do something similar in, say, Gemini or in ChatGPT, it will give you a number and you'll have to constantly keep cross-checking that with ChatGPT. It may give you an answer, so that if an R square number, for example, is less than 60%, it's not a great model. It has to be 80 and above. But ChatGPT might tell you 60% is okay because we have less number of data. You don't want that to happen. So you do the right kind of tools. That's number one. Number two, the model should ideally always have explainability. AI or any other model that you're talking about, it should always have explainability. Why is this model giving you the response that it's giving? And is it able to explain that entire thing? The working of it, the result of it, the assumptions that it's actually taking. If it's not able to explain itself, then we are in a soup. Then I don't want to trust that model at all.
So how do you there is a terminology called black box in ML. So healthcare professionals are really afraid of the term black box. So while treating their patients, so how do you fade away the fear of black box in whatever ML technology that we bring into our patient care?
So if I were a doctor and if I'm using any of these technologies, one of course is I would move from and this could be controversial, but I would use ChatGPT instead of OpenAI. I would use Claude instead of ChatGPT, purely because so the great models, both of them again. Perplexity again is a great model, but personally, I just feel that Claude t- tends to understand the data and other pieces a lot better. So I would use that. And then for a black box per se, I would again always ask my model for tell me which data, so cite me all the sources if you're telling me any data, number one. Number two, show me the working and algorithm, something what Google Colab does. So it actually takes you step by step, it imports the right kind of libraries, it cleans the data, sets the kind of columns that you want, and you're able to see it. Which is why for ML, if I have to do an analysis, I would not do that in any of the LLMs at all. I would do all of my analysis first in Google Colab. I learn from those particular pieces. I generate my graphs and summaries and everything else, and then maybe take it to Gemini in a more visual fashion. And again, in Google Colab, also, I don't have to be technical to be able to do it. There is a Gemini section which actually helps me to do that. The benefit and the beautification of what Google Colab is that it's not an AI model. It does not have a brain of its own. It only runs and imports the right kind of libraries and it only operates on the data that you have fed, which gives me a decent, or at least some confidence. It's not black box. You can see the working happening there. It is explaining how it's doing what it's doing. And more importantly, it's only working on your data. So that gives me a sense of confidence of whatever I'm doing and I'm building is the right thing. And again, I'm not trusting it 100%. It is giving me the first line of treatment, first line of explainability, first line of understanding of the case. It takes me into that, and from that point onwards, it gives me and gets me into the direction. That's how I would do. I would not trust any of these machines 100%.
So to understand
We have
finally
two more
these,
questions, Ramakrishna sir. We have two
yeah,
more
yeah.
questions.
Do we require a stringent regulatory approvals so that doctors could safely use these ML tools?
100%. So we are far away as a country. We are far away from there. A lot needs to be done with in a public-private key setup, wherein the government supports us with the infrastructure and the private organizations such as ourselves. We are actually able to drive and deliver grassroots level research, and we build models with doctors. We build models with hospitals to be able to do it. And we bring the technology know-how to be able to even test these models at scales with millions of records before this trust can actually be delivered and handed over to the doctors. So definitely there is a need to invest in this paradigm.
But yes, sir. Thank you, Sumit. So just a small last point to comment. So India is in a fascinating situation with Ayushman Bharat digital mission, digitizing healthcare data with the digital India concept and trying to rope in all GPUs or AI/ML. Uh, how do you imagine or project the healthcare which that India is witnessing in the next decade?
Oh, I would. Man, this is a fascinating video that I saw, wherein this one person, in fact, it also happened with a friend of mine. He was traveling to one of our neighboring countries. Went into a hospital, scanned a QR code, and his entire, just like an Aadhaar card, his entire history was brought in. His insurance was brought into the same panel. His liabilities and insurance claims, and the third party providers and everything was kind of notified that this person has just checked into the hotel. He did all of his scans, and there were scans are available in his WhatsApp counter, something like a WhatsApp app. So these reports are available to him for to see. The reports were sent to the doctors. He could get onto a call before he even entered into a doctor's room. The doctor had the reports in front of it, along with diagnosis and the first line of analysis using AI. So a seamless, paperless, cashless healthcare system wherein you meet a doctor when it's absolutely important and it's actually delivered. We have Blinkit delivering goods in 10 minutes. I envision healthcare being delivered in 10 minutes or faster. And not just in life-saving conditions, but also in regular conditions. That's the kind of medical system is what I would envision in 10 years from now. And we can totally get there. We have the technical know-how. We know how to build systems at scale. We know how to deploy things at scale. It baffles me when I see that these possibilities are not being shown at this point in time to the world.
Yeah, last question. These ML
Sure.
and AI algorithms are going to unmask a lot of diseases, which is going to restrict insurance applicability to a lot of Indians, especially private health insurance. So, is ML going to be enemy for Indian public for getting private health insurance?
Absolutely not. In fact, on the contrary, if we are able to uncover and identify some newer diseases, we can proactively work with insurance companies to be able to get better cover, which would only help improve the lives of people. If we know that there is a particular something that happens only after 87 years of age, and with life expectancy
I want
growing, these
Dr. Suresh opinion also on this.
Sure, sir.
Because insurance is restricting a lot of diseases. So finally bringing a lot of milder varieties of disease with ML. So the denial rates will also be higher with insurance.
So Dr. Ramakrishna, I'll just tell the other perspective because I have been advising to IRDA in a different uh, board altogether. So you cannot deny uh, insurance just because you have a risk of getting it. As long as you declare, the insurance company is having a right to take more premium, but it cannot deny. So that is one of the rules that IRD has put. So we are less worried about it.
Good point.
So
Yeah.
it's always good. They can ask better premium. And tomorrow, if they deny saying that it is pre-existing, they can't do it just because it is already declared by the ML. Actually, it is more dangerous to the insurance companies than to the patients. So we have a couple of questions missed,
Please ask.
hallucinations part of it, right, Ramakrishna? I think we have seen a lot of questions.
Especially in large language models.
How do you know that the ML is not hallucinating too much? And just like how do you score people? How do you give marks to the learning? What mark is considered as a pass mark for the machine learning? So these are the few interesting questions they have asked.
These are brilliant questions again. So machine learning does not hallucinate.
Right.
Okay. AI hallucinates. And these two things are very different. ChatGPT hallucinates, but when I'm actually importing a library of Python and I'm actually doing a forest analysis or some other analysis, that's not hallucinating. It's data. It's data doing data analysis and giving you some scores. What do you understand of these scores and using AI to understand that may be a hallucination. But a 0.85 is a 0.85, right? So it's very important to understand, and oftentimes we confuse AI as ML and AI as ML as AI. It is very important to understand, and in fact, ML, AI, and Gen AI are three very different things. Within AI, also there's traditional and there is generative AI. ML is purely machine learning, and then after ML, there is traditional computational. So what is not machine learning, right? If we have deterministic outputs, if we have if then else, that's not ML. So understanding what kind of analysis do you want to do is the first line of defense that you would ideally want to put together. So as you're starting to do something, and ChatGPT is great. Now remember when I shared, and please go back to the recording to see my prompt, I highlighted that. Play a devil's advocate. Find the gaps and fix it for me. If I have time, I would have gone ahead and said, do this twice. So it would twice go ahead and take a step back, look at the response, be critical about the response that it has actually generated, find the flaws in it, and then be able to do. And there is also the previous session you must have read about giving a role. So while you're doing these analysis, you give that role of a senior data analyst and a medical practitioner and assume any role that you want to give me the most accurate response. That's my opening role line. Then my ending is playing a devil's advocate. And then lastly, give a summary and explain your reasons why. These three things in your prompt will actually reduce hallucination in a good way. So
Great.
that's my way of handling hallucination. And ML is not hallucination, ML is pure science.
Perfect.
Which
So
is how we
ML
do it
is
in
a
Google
pure
Colab.
science. That is a strong statement by Sumit. I think we doctors should know that anyone comes with ML as a thing, it is a learned thing. It is not a poetic or imaginary thing. Is
But
that right,
however,
Sumit?
one thing very important is, and I often hear it because I do have doctors in my families, and they're extremely wary of the patients who come with ChatGPT knowledge. And when these patients are essentially coming with ChatGPT knowledge, I would just ask them, okay, what did you ask ChatGPT? Because if you don't know how to talk to the machines, then the response that you are getting is going to be completely wrong. They may be in a completely poetic fashion, ask something about it. They may get a poetic response and they may romanticize the output. They go to a doctor saying, oh, now I know what I am suffering with. That is so wrong. So the ethical responsibility part of, and this is an added burden on doctors, is to educate their patients to please do not trust your chat GPTs and your LLMs at all.
Great.
And
So I think we touched 5 o'clock. We have a hard stop here. And for those who want to directly communicate to Mr. Sumit or want to route the questions to Dr. Ramakrishna, you're most welcome to do it. In the presentation at 42nd minute, you have the QR code where you can reach out to Sumit sir, and his mail ID is available at National Board Examination Sangam portal. So the feedback link is will be active in another few minutes, and we will put a request to the IT cell of NBMS to reshare the Guinness World Record, which you have to download by yourself. NBMS is not going to give any certificates. It will give a link for you. You can write your name and then download your own certificate. So with these few things, I hand it over back to NBMS for closing remarks if they have.
Thank you, Dr. Suresh sir and Dr. Sumit sir and Dr. Ramakrishna sir for this wonderful session. Thank you all of you. Thank you so much.
thank you.
Thank you.
Thank you
Have a
very
good
much.
day.
Bye. Good day.
Bye bye.
Bye-bye.